Okay, so it's the 12th of July, and this is an open source antibiotics update meeting for the Mur Ligase series. And I posted a very sort of sketchy issue yesterday. The recording is up of last meeting, and I posted a very sketchy update for this meeting. Apologies for that, but I just took the most important things and put them up there. And I mean, we can take these in any order and deal with the most important things first. I guess from my perspective, the two things that we should start with would be, you know, as a result of the exciting data that were presented last time by Adrian, whether we have any updates on that work from Adrian and Laura, and then also whether we have any updates on the structural biology. I think that Jan is not here, but whether we have any new structures that we should be talking about. Because I think that there were lots of, Jan's just joined. There were lots of things, I think, on the stove, as it were, that people were thinking about, what people are trying, and it'd be great to catch up. So Laura and Adrian, you are both here and ready. Did you want to lead off?
Yeah, we're going to start.
Okay.
Yeah, is that all right? So shall I stop sharing?
Yeah.
All right.
Can you see my PowerPoint? Well, our PowerPoint.
Yeah, all good.
Good.
Okay.
So let me just put the there you are. All right, so I'm just going to start with my update. Because I can't see anything with this. I can't move it well. So I've been doing a few things for crystallization. So I have been following up the main hits from the last structures for E. coli and Mur D, so we can use them for XChem and soaking. In the case of Mur D ADP, I got a surprisingly less proportion of crystals than I was expecting. I was expecting it to be more successful. I did some soaking into those crystals, but they were dissolving like milliseconds after adding the compounds. So I think I need to try with another condition for Mur D ADP. Then in the case of UMI, the monopeptide, I've got some crystals, more crystals than with ADP, but the compounds were precipitating in the crystallization condition. So I think they were impairing the soaking. Still, I've got some crystals soaked, and they have been sent to diamond. Also, I want to try another condition for UMI, given that that condition was precipitating the compounds. Next, I've done co-crystallization with the 4 hits, the top hits that we are working on. And those, so I don't have any crystal growth yet, but there are still more things that I can try. So that's going to start in the round 2 of the co-crystallization. And it will involve 3 proteins, Mur, C, D, and E, with the compounds. So let's see how that goes on the crystallization. E. coli,
Chris, you had a question. Sorry to interrupt, Laura. Chris had an
Just back on the first one, Laura, was that a solvent problem causing the crystals to dissolve, or a compound problem? Did you,
So,
I'm fingers crossed you used a solvent-only control?
yes. So with the DMSO only, it didn't seem to be dying. Right,
Okay.
we don't know because I haven't tested the fraction, but it was only when the compound was added. So something must be happening, probably. Yeah, some conformational change of some kind that is breaking down the crystal. I don't know.
Okay, thanks.
Yeah. The same with the Mur D crystals, and there was nothing happening with the DMSO control. It was fine. Yeah. Next, this is a summary of all the soaking. I also soaked into APO crystals for E. coli, Mur D, and Mur E. Sorry, D and E. Again, all that is going to diamond. Solubility, there were solubility issues with the compounds again, but less issues than in the case of the UMI crystals. And yeah, I also prepared some more E. coli Mur E crystals for the close conformation with different concentrations of the tripeptide, but I haven't got any crystals yet. And I also started co-crystallization with Pseudomonas Mur C and a monopeptide. And again, I got no crystals yet for that. That's all my update on crystals. The frozen
Laura?
crystals have gone, yeah?
So what concentration of the compounds were you using?
I will need to check because it's different concentrations. I try different concentrations. Millimolar concentration of compounds.
I'm sorry?
Millimolar concentration, but I can't
Yeah,
remember
so if you go back and look at Adrian's results, I think some of the compounds were down in the, whatever, 20 to 100 micromolar inhibitors.
Yeah.
So I'm just wondering,
JO6.
So I tried to dilute them as well. I need to, again, I need to check my notes on the soaking because I did a lot of things. I did a lot of
okay,
time
I'm just
and I did a
wondering,
lot
you
of
know,
compound concentrations as
Right.
well. So I started with millimolar, okay, and then I did dilutions as well. So I was basically based on the percentage of DMSO, as I know this compound, these crystals don't go more than 10% of the DMSO. So, and I started with that and then diluted down, but everything was the same.
okay. I just thought maybe, you know, if you're doing high millimolar concentrations, if, you know, if you could get by with something like 100 micromolar, but maybe you have already done that experiment. You said you've done dilution, so if you did a
Yes.
10-fold dilution, I assume if you started at 5 millimolar or 1 millimolar, you did 10-fold dilution, then you would be down in the
Yeah,
100
if I remember
micromolar range.
correctly, I started with 2 millimolar because one of them, the solubility was already not that great in the first dilution that I did with 100% DMSO. So I started with 2, if I remember correctly. But again, I want to check again because I did a lot of things that day, not only
Okay.
this project. Yeah.
Okay, thank you.
And then, yeah, and finally, so samples have arrived to Diamond, and I'm just waiting to get beam time so I can check all these experiments.
I just wonder, Laura, what do you think? Clearly, there's sounds like there's a structural change going on. So it might be either it can only be done by co-crystallization, or is it possible to do some ligand exchange interaction at the binding site if we had some really weak analog present in the site where the inhibitor is? Is it possible to do some kind? Is that even a thing where you can kind of do an exchange so you can kind of maintain the structure somehow? Or does that not happen?
So that's what I was trying with the ADP because they're ADP competitive.
It's already in there, yeah.
Yeah, and I was like, it should supposed to be already in there. So that's what I was trying to avoid.
Understood. Yeah. Okay.
Yeah. But again, if the thing is that if these crystals are very sensitive to any changes, then they will dissolve. So that's why I want to try with another condition and see how that works.
Yeah, I would think that the UMA system would be the best system to try.
Yeah, I mean, I'm just trying different things in case we can.
Yeah, I understand. I'm just saying, I think out of the systems, the UMA system without ADP bound would be more favorable for these compounds, but that's just a guess, I guess.
Yeah.
My only thought then is if you were doing for that ligand exchange, then actually you really want the higher concentration of compound to make sure you fill the replaced site as fast as possible, I would have thought. Yeah,
so for those ones I started with a higher concentration. This is why I'm saying like I'm doing a lot. So I started with double the concentration of the ADP that I was adding. Yeah.
All I was going to ask was, are you doing this in the presence of magnesium as well?
Yes.
Okay.
Yeah.
So it should be the authentic true double chelate or the ADP that's in there.
I even added more magnesium in these structures in the Eyermann because we didn't see in the structure the magnesium bound, so I even added more.
Okay.
Yeah. So that's everything. I hope we can test the crystal soon and that we get some co-crystallization.
That's great.
Actually, Laura, so you're just making the comment about magnesium. So that's kind of a little tricky, I think. So if you look at the structures of UMA ADP bound with magnesium, at least based on how we're thinking some of these compounds might be binding, the magnesium actually may be blocking. So if you have so I was thinking, I don't know if you did any experiments with UMA with no magnesium. I don't know if that's even possible.
I've did that as well.
Okay.
So I've got the initial magnesium concentration with UMI, no magnesium, and then a higher magnesium concentration.
Okay, great. You sound like you're covering all the bases.
Yes.
There's one thing that might be useful to know. So when in years gone by, we were setting up the synthetic routes to make the precursors, one thing that we did notice, as far as the pathway was concerned, there was a definite optimum for magnesium, below which the pathway operated suboptimally, above which it definitely was also suboptimal. And I do wonder whether if you get the concentration of magnesium too high, that you're actually binding the chelate of the UDP substrate. Because if you look at the co-crystal structures of the UDP substrates and ligases, those phosphates bind directly. Meanwhile, the nucleotide ATP binds as the magnesium chelate. So it's a balancing act. It really is. And I think it could be something that be quite sensitive to the magnesium concentration to go to work or not.
Yeah. Well, we've got soaked in the three of them. So
Yeah.
Let's see what happens.
On the screen there, the things that have been sent to Diamond are, I guess just to paraphrase, the E. coli Mur D with the ADP are right at the top.
No, that one, I couldn't get any of those crystals.
Okay.
They're all melted.
All right, so what's been sent? Sorry,
So I've sent E. coli Mur D UMI,
right,
without magnesium and with the 2 magnesium concentrations.
Yeah.
And the APO, E. coli Mu E and E. coli Mu D.
Right.
In the presence of the compounds, yeah.
Okay, and in each case, are these including all of the promising enamine small molecules, or one?
Yes.
Or
All the four of them.
Four.
Four.
all right,
They were sent today on one of the messages in the issues in GitHub.
Yeah.
So 4 of them, yeah, those 4.
fine, great, okay.
Probably just worth recolor coding, Laura, samples at Diamond and which ones to just post it with the color coded so people can spot which has been sent.
Yeah, I can do that as well.
Yeah, great.
Fantastic.
Good. And now Adrian.
Okay. So this will be fairly quick. So this essentially is finishing off a section of work which I was basically gave the presentation last time about. So this concerns Pseudomonas aeruginosa Mur E and hit number N15 from the enamine library, which basically is singly targeted Mur E. And this turns out to be a little unusual in that if you look at the saturation of the percentage inhibition versus N15 concentration, with this particular molecule, you don't get, you get what looks like partial inhibition, and the half maximal effect is around about 25 micromolar. Partial inhibition, if it's true, basically means that the molecule is occluding the active site, but not to the extent where it actually shuts down catalysis. At the moment, and going forward at the moment, we have 2 students, 2 undergraduate students who I'm training up at the moment to work in the ligase area. And we still have, and they're going to be pursuing the Mur C hits, and they're going to be pursuing the hits that we've got with D&E against Mur F. So we'll have a picture that goes down the entire pathway, hopefully by the next meeting. And that really is the rather short update I'll have for you at the minute.
When you say that it can completely occlude the active site, are you saying this is an allosteric inhibitor?
No, I don't know. Well, all
Okay.
I'm saying is that it's behaving rather like a class of inhibitor that normally, when we think of the common types of inhibition like competitive or uncompetitive and so on, the enzyme complex with the inhibitor is inactive. In the case of partial inhibition, in that particular case, the enzyme inhibitor complex actually has some residual activity. So you can never push the system to complete inhibition. And one possible interpretation of that is that the molecule in question, N15, overlaps or is adjacent to the active site and impedes but does not prevent the access to substrates to the active site. But it's something we'll be following up as well.
Yeah. Interesting.
Yeah.
Okay, fantastic. The two students you mentioned, if they are thinking about anything to do with compound design, it would be good to involve them in the project, for example, on GitHub, because Ed and I have been talking a little bit about this, and I'm sure Joe is really interested in thinking about compound design, building on the molecules that have been obtained so far.
Yeah.
Just to try and loop them into the project, that would be great to make sure we're not, duplicating each other.
Yeah.
All right, great. Was that the last slide?
Yeah, that was
Yeah.
it.
Okay. All right. Anyone got any remaining questions on the work, the two slides that were just presented? Okay, great. Thanks.
Yeah.
All right, Jan, you've joined us. Do you want to present or discuss anything? I think you were pursuing an important structure or two last time. Wondered if you had any news.
Yeah, I just have a few things to update. It took my colleagues a while to peer review the structure. That's our standard in-house process. So that finally happened last week. So I will deliver the structure this week. That's the plan. Then a curious observation was I've been trying to co-crystallize the Acinetobacter murd with UMA and got a number of crystal forms, but they were all in the apo conformation. So I could never get any UMA bound, which was very surprising because it worked just fine for the Pseudomonas construct. And then lastly, for the Pseudomonas mur, I had a couple of weeks ago discovered a new crystal form with 1 molecule per asymmetric unit, which was much nicer than the 8 molecules per asymmetric unit of the previous crystal form. Goal was to regrow these crystals and use them for soaks for the AZ compounds. The provider of our optimization screens, they had issues getting a compound delivered, and then they had a corona case in the office. So I hope to get this screen this week, and then we'll grow crystals and do the soaks. So there was some delay on a couple of frontiers with these crystals, but hopefully this week we're moving forward.
Okay, great.
That's all I have.
Thanks.
Mhm.
Great.
Just for clarity, Jan, those are the 4 compounds that were sent from AZ, whatever, several months ago.
Yeah, exactly.
yeah.
Yep. That we have seen really good shifts for. Yep.
Right. Thank you.
Mhm.
Right. So those are the I guess those are the main things that we wanted to talk about. Of the others, I mean, there are lots of little bits and pieces here. Just move that out of the way. So I guess one of the things that we were interested in, and Laura, you've been busy with lots of other things, as you just described, was I guess there was a residual issue about whether the atomized compounds were giving any inhibition. Has that experiment been done? I mean, measure them in the enzymatic assay.
Not yet.
Okay, but is it scheduled? I mean, you've got the compounds and it would be possible? Okay, all right, because obviously we got the structures for these guys and we didn't know if that was going to translate into inhibition.
Yeah, exactly. We are actually, Adrian and I are having a meeting in a couple of days to organize all the compounds.
Okay.
Yeah.
All right, great.
We also got new compounds from Edwin.
Yes. Yes, that's right. So the compounds that were delivered, and you know what, I'm just gonna I can't find the, oh yeah, there you go. Yeah, these compounds were delivered. These are the fragments that have been elaborated further with some semi-random changes based on some of the previous elaborated fragments that we got that appeared to be inhibiting more than one Mur. So a separate line of inquiry, but the compounds are looking all right. So a bunch of compounds have been shipped that Ed and Kato have made, and they've now hopefully arrived. As well as the first two competition entries.
Yeah.
And
the second two as well. They just arrived. So,
oh, yeah.
Yeah, Ed, I will send you as soon as I can the 50 milligrams compound thing. I had to send Ed some compounds, so I will do that.
Yeah. Okay.
But yeah, they just arrived like a few hours ago.
Okay, great. So yes, just to summarize, we've been working since about March, I suppose, on securing molecules predicted to bind where the original fragments were binding. The original fragments that we pursued and which those molecules are derivatives of. And we started this AI machine learning competition, asking people to use generative methods to design new molecules that might bind those areas. Someone who's been on lots of the previous calls, Jan Jensen, suggested some, and there were several other entries that came in, and some of those molecules have been bought, and some of them, I think those are being shipped directly to Laura where we can do that, and others are being made by Ed and by Daniel, who's also on the call. And the idea is to complete this set and send those for evaluation by Laura to see if we get any hits. So it's competition. We're going to see what works best. And everyone here has used different methods. So it's a kind of modeling competition with a crystal structure as the target and no other clues besides where those fragments are interacting with the protein. Yeah, we'll see what we'll get. We may get nothing. Hopefully we'll get something. These are all probably going to be weak binders. So certainly SPR and soaking will be the best way to go. But we'll see what we get, I guess.
Mm-hmm.
Just to flag up, if some of those molecules are being delivered directly to you from the commercial suppliers, from Enamine, then, I mean, I know you will do this, but please keep those to one side. We kind of have a plan, because we're generating lots of molecules at the moment, we kind of have a plan to try and develop a little bit of a kind of in-house screening library that could be used for other campaigns. So the molecules generated for this and for parallel projects, we're trying to make sure that we keep stocks. And so for the molecules that we're ordering here, it'd be nice to have little stocks of those. So for those being directly delivered to you, we may at some point try and get those back.
Do you want dry stocks or?
Well, ideally, I mean, we probably keep them as DMSO solutions in the freezer. That's probably the way we're going to do it. But if
yeah,
it's dry stock,
I don't know if I can, because it was a low milligram. I think it was 5 milligrams. I'm not sure I can separate that.
Yeah, I mean, you tend to keep them as DMSO stocks. Is that what you tend to do?
Yeah.
Right.
Yes.
Yeah, I mean, that I'm pretty sure that will be okay. We're not quite sure how we will store molecules generically at the moment, but DMSO stocks are a pretty good way to go for us.
Okay. Good.
Okay. So that's good. Okay, so you're having a local meeting to decide when to deal with those molecules, which is fantastic. Okay.
Yeah, and other things. Yeah.
Okay. All right. The other thing, so I was hoping that Yuhang could update us on his campaign to generate this amino derivative of the original AZ Mur-C hit. He's posted an update slide here. Yuhang, did you want to briefly talk us through this?
Yes, sure. So basically for the first part, I eventually managed to synthesize the aiming AZ595, that compound, and hopefully be able to ship it to the SSGCID and Laura. So the synthetic process was extremely weird because you guys can see the bulk protected intermediate was was really, really hard to separate. It got stuck in the reverse phase column. It also cannot come up from the normal phase. The only way to do it is to use amino normal phase column, then further purified by HP, yeah, LCMS prep. Basically, it's HPLC, and then still cannot separate the bulk protected product with the starting material. So I have to carry it as crude to the next step, TFA deprotecting. Then because the drastic change in the polarity of the compound, then eventually I've been able to separate this product from the impurity starting material, the chloride on the left-hand side. So that 6 milligram can be improved. The yield can be improved drastically in the future, because this is my first time doing this reaction, and there are so many ways during this testing period. So it should be improved later. And then we can move on to the micro ED samples.
So just on this compound, obviously,
yes.
The thing we need to do is to check that it is active again in the enzymatic assay, right? And this would be Mur C.
Yes.
Because this is the analog of the original AZ compound, where this NH2 is an OH. So I guess we're keen to try to send some to Warwick to make sure it works, and then if it does have inhibitory activity, then the next thing will be to test it on bacteria.
Yeah,
because the aim is to
I'm thinking about sending it as a salt form, because now it's like super hot outside. I worry about the delivery.
Well, keep it in the freezer.
Can we
we'll keep it outside?
Yeah. Okay.
Okay. But maybe we can be in touch offline about sending that compound and how much might be needed.
Yeah. I think we'd go straight to the microbiology as well, to be honest, because if we've already seen, we've already got a benchmark for AZ activity. We can check that out straight away. Be quicker.
Right. Okay. Great.
And now it's the first batch we have already sent to the Diamond, and these molecules are under the progress being tested. And the second batch is are the compounds I've already made, but ready to ship. Just ready to ship. Yes.
These are structural elucidation things. So we're trying to get structures of these compounds by micro ED. That's also trying to accelerate how we're doing structural elucidation, but it's not directly relevant to the stuff we're doing in finding bioactive compounds. It's just that we're trying to accelerate things.
Is it macro ED with the protein or just the compound?
Just the compounds, right? So yeah, we're trying to get structures. It's like a rapid. It's like getting X-ray on something using electron diffraction.
That's why now it's getting more famous for protein. So
yeah, right. So now small molecules.
Yes.
And I guess the comparison that we're always wanting with the new amine is with the corresponding other compound, which I believe has been sent right to various places. So Yuhang, do we know who has this compound already, and so who can then compare it with the amine?
No one has this compound. I'm about to send them. Yes, and also I'm about to send these 2 compounds to the SSGCID as well. You can see the second part, Warwick and Seattle biological testing and crystallography. So that's the first compound have already been sent last year by August, and we are waiting for the PDB file being available from the database. I think I checked today and still not available. So we just need to wait, I guess.
I'm sorry that Peter isn't responding. I will bug him and his boss to get things moving. I don't know where the holdup is.
I think he has already deposited it. Because he got both my Matt and my what's that called? ID. Is that that ID? So, but please do. Thanks.
Yep, I will.
Okay. Yeah, this is just some results we got from Diamond showing the direct structural elucidation of a molecule. where we weren't quite sure where the methyl was, and it shows it nicely.
And they eventually managed to get the crystal of this.
Yeah, great. All right, great. And then you made a start on Jensen's original set of compounds, which were predicted some time ago.
Virgin 17, yes. And just trying out different conditions and synthetic sequences. That's all.
All right, great. Thanks, Yuhang. All right,
Sorry about
good.
the delay.
All right, yeah. So Yuhang, I guess you've clarified which compounds have been sent where, and we just need to make sure that those compounds have been evaluated in some way. So this action here is on a compound that was sent to Warwick. Yeah.
Sorry, I forgot to.
This guy, right?
Yeah.
All right. So that compound's already at Warwick, when we're going to also ship these two, which would make a nice set, I think. Okay, good. I think those are the major things that we're talking about. So, I mean, I just want to make sure that if there's anything that's crucial and important or has recently happened, that people have a chance to update us. Yeah, Chris.
So the agreement between Warwick and LifeArc for LifeArc to pass on the compounds to the Open Source Consortium has been signed. And,
oh, wow.
And the compounds are in the post and may arrive today. We've had all of the structures sent to us, and the supporting information will be on the way as well. So
that's amazing.
That's happening. So we'll update next time once we've actually got them all, to give you a list of what's arrived and what they look like. So we'll assemble that into something so people can have a look at what the structures are, what's come through from LifeArc. But they will feed into the assay pipeline. The second thing about the assay pipeline is that we were held up with the continuous assay that we have for the data analysis. So we've got an IT project on at the moment this week to get a nice little script to be able to get the kinetic constants out of the continuous assay to be able to identify where the linear slope is, etc., and work back from that, the inhibition. So that's ongoing this week. So we're hoping that our throughput will accelerate quite substantially soon, within the next week or so, in advance of any advances on the stopped assay. I mean, to be honest, we need another pair of hands. I mean, I'm writing furiously for fellowships at the moment to get more pairs of hands, all sorts of places. So, but anyway, it's some progress, good progress on that, I think.
Yeah, that's great. Wow. Okay, next time. Okay, I think that was everything. I think last time we'd agreed to wait to reach out to CC4 Carb until we'd perhaps got fleshed out some of the more recent data. So, for example, getting a structure and so on. And I think, Chris, you were chasing on the Global Global Health Library in case that could come through. I think that was a contracts.
Yeah, no, that's still
fine. Okay, yeah, it's useful if we can get it, but I know it takes a while.
Yeah.
There is something which isn't up here, but which is on a parallel project that we have going on a fungal infection. That UNESCO are asking for written submissions on open source projects as exemplars of how to work with open science. The deadline is like Friday. It's a pretty simple form. I need to submit one for a couple of other projects. I'll try and submit one for this project, and I'll try and post the text somewhere so that everyone can see it. I may have to write on everyone's behalf, but it's a kind of high level description of the project. Here it is. I have it open. So they're asking for call for best practices in open science, and I think we are a really good exemplar of this, addressing something that's really important. So they're asking for someone to submit something here. I'm assuming no one else has already done this, and I'm assuming that the text that I would write, there's some free text down here, which is like 300 words on best practice and something about other things. I'll put something in there and I'll try and share it with everybody, but I don't think it's going to be controversial. And I'm assuming that I'm okay to name people who've publicly contributed to the project if that helps us.
Yeah. I'm assuming they don't give you any money as a result of this.
Yeah, I think you're probably right. But yeah, you're probably right. But I guess I'm keen to submit something because there are quite a lot of open science projects which are ultimately about open access and things like metadata and stuff like that. And there are actually relatively few open science projects which are actually doing it in the way that we're doing it. So I'm keen to try and slot something in there so that people at UNESCO understand what it is we're doing and how it's different, I suppose.
Yeah, important.
Yeah. So yeah, I'll try and do that. I'm also, so in a couple of weeks, I'm giving a talk at the Gordon conference on new antibacterial agents. It's a week-long thing in Italy. Usually I'm on the last day, so I'll be able to listen to everyone else's talks and then talk about what we're doing. Again, I'll really try and share a deck before that, or share it around so people are happy with it. The aim, of course, is to acknowledge everyone in full. So I'm speaking only on behalf of this group, and also on behalf of another group, Series 2 in Open Source Antibiotics, which is not related to this one. But again, I'm not saying anything which is not already public, and I will be very, very careful to make sure that everyone's acknowledged suitably. But that talk is, what is it, the 28th or something? So before the next meeting, but I'll send the deck round or post it somewhere. I may come to a few of you for some information about that, actually. I'm lacking in key information.
I anticipate you to see Terry Romer there, so give him a big thanks for his review.
Yeah, right.
Publication.
Yeah, right. Yeah, no, it's a really interesting looking meeting, and it's really good that I'm able to talk about this project now. Interestingly, that meeting was cancelled right at the beginning of the pandemic in 2020 because there was a spike in cases around Naples, which is where the conference was. So it was the first thing I saw of to be cancelled. And it's due to start in a couple of weeks, and I'm just hoping the cases stay down to avoid a grotesque repetition of history.
Sadly, yeah. Matt, I think it will be.
Yeah, well, we're all a bit nervous. All right, was there anything else anyone wanted to raise? That's been very useful. All right, if not, great to see everybody, and thanks for coming.